Hey everyone, welcome back. Today we're tackling an absolute game changer in cognitive science. Think of this explainer as your ultimate exam review summary for cognitive depth and the levels of processing model. Seriously, if you've ever wondered why you can reread a textbook chapter like 3 times and still completely blank on the test, or why some random passing comment from a friend sticks in your mind for literal years, well, you're in the right place. We're going to master exactly how human memory actually functions, ditching the old school ideas and diving deep into how your brain is processing information right at this very second.
Okay, let's look at our agenda for today's session. 1. The structural theory rebellion. 2. Depth, shallow to semantic. 3. Proofreading versus gist reading. 4. Experiments and self-reference. 5. Critiques of the LOP model. And 6. Final exam quiz and glossary. Let's jump right in.
Section 1. The Structural Theory Rebellion. You know, to truly get a scientific model, you kind of have to understand what it was fighting against. For a really long time, the dominant theories of memory, like the classic Atkinson and Shiffrin model, relied on this rigid boxes-in-the-head scheme. They basically pictured memory as this strict sequence of structural components. You know, first a sensory store, then it gets boxed into short-term memory, and finally boxed into long-term memory. But then in 1972, researchers Craik and Lockhart totally rebelled against this. They proposed the levels of processing, or LOP model. They argued, hey, memory traces aren't just objects getting shuffled from one structural box to another. Instead, memory is actually a byproduct of perceptual processing. They dropped those rigid boxes entirely in favor of a dynamic spread of processing, where how long a memory lasts depend entirely on how deeply you engage with it.
Section 2. Depth, shallow to semantic. So let's walk through this flowchart to see how processing depth actually builds. It's kind of like a giant puzzle. Imagine you're just looking at a word. At step 1, the absolute shallowest level, your brain just does a sensory analysis. It's just processing the physical features, literally just lines and angles. Then, moving to step 2, a slightly deeper level, your brain kicks into pattern recognition. It matches those lines and angles to stored information, recognizing, oh, hey, that specific shape is the letter A. And finally, at step 3, the deepest level, you extract semantic meaning. This is where the recognized word triggers associations, imagery, and stories based on your own past experiences. Craik and Lockhart's whole point is that if you only process something at step 1, it's gone. It's easily forgotten. But if you push it all the way to step 3, fully attending to it and enriching it with personal meaning, that memory becomes locked in for the long haul.
Section 3. Proofreading versus gist reading.
This perfectly illustrates the difference in cognitive activation, and it's something you probably do every day. When you're proofreading a paper, your brain is doing what we call elaborate shallow processing. You're hyper-focused on the surface stuff, right? The spelling, the grammar, the physical layout of the letters. But you're doing very minimal semantic processing. I mean, you could fix 10 typos in a paragraph and suddenly realize you have no idea what it actually said. On the flip side, gist reading involves minimal shallow processing but elaborate semantic processing. You're reading just to grab the essential points, totally glossing over the exact letter sequences to get the big picture. It's the exact same text, but the way you process it completely changes what gets stored in your memory. Think of a super fast typist who perfectly copies a whole manuscript but couldn't tell you the plot if their life depended on it. They were totally stuck in shallow processing.
Section 4. Experiments and self-reference.
Okay, cognitive psychology is all about rigorous testing, so let's look at the proof. Back in 1975, Craik and Tulving actually put this to the test in a lab. They had subjects rate words based on different aspects. If a subject just rated a word's structural features, like, is this word in capital letters, their recall was the absolute poorest. If they rated phonemic aspects, like, what does this word rhyme with, recall got significantly better. But if they rated the semantic meaning, like, does this word fit into this specific sentence, recall was far and away the best. They also proved that deeper processing physically takes more time to do, but man, the payoff and recognition is massive. You're basically trading processing time for memory durability.
Now here's where it gets really fun, because we can actually hack this system. In 1977, Rogers, Cooper, and Kirker discovered the self-reference effect. They ran a very similar experiment, but they added a task where subjects had to evaluate if an adjective described themselves. And the result? No way, it was crazy. Self-reference words absolutely blew all the other categories out of the water for recall. When you link information to I, me, mine, you're tapping into what's known as the narcissistic trait. We all have this massive, complex, heavily invested internal network of information just about ourselves. Because you know so much about you, evaluating a word against your own personality fires up these incredibly deep, elaborate brain structures, giving you vastly superior memory retention.
Section 5. Critiques of the LOP model.
Because, let's be real, no theory in cognitive science is perfect, and the traditional information processing theorists definitely pushed back. Critics, especially Baddeley, came forward with some pretty sharp arguments. First off, they argued the model just states a really mundane conclusion. Meaningful events are well remembered. Well, yeah, we kind of already knew that. Second, they pointed out that the whole concept of depth is super vague and generally untestable. But the third critique is absolutely crucial. They accused the model of circular reasoning. Think about it. How do we know a memory was deeply processed? Because the person remembered it well. And why did they remember it well? Because it was deeply processed. You see the loop there? Without an objective, independent way to measure depth, outside of just looking at the recall results, the logic just completely circles back on itself.
Section 6. Final exam quiz and glossary.
All right, let's encode these concepts into your own long-term semantic networks. First key definition, maintenance rehearsal. This is when you're just repeating something over and over at a shallow level, like muttering a phone number to yourself just long enough to dial it. According to the levels of processing theory, this merely holds information at one single level of analysis. It does not lead to better retention. So listen up. If you're just rereading your notes without actually thinking about what they mean, you're doing maintenance rehearsal, and it is not going to save you on exam day.
Second definition, self-schema. This is that organized system of internal attributes built entirely around you. It's a remarkably rich network for storing information. If you really want to remember these cognitive science concepts, don't just memorize the definitions like a robot. Ask yourself, okay, when have I used maintenance rehearsal? Or how does this theory explain my terrible study habits? By forcing the material through your own self-schema, you trigger the deepest semantic processing possible.
All right, let's see if you're doing some deep processing just now. Here's your first practice quiz question. According to Craik and Tulving's research, which specific level of processing requires the most time to accomplish and yields the highest rate of recognition? Take a second, retrieve it. If you said semantic processing, you hit the nail on the head. Extracting meaning takes longer, but it absolutely gives the best memory results.
Let's try one more. Question 2. Why do critics argue that the levels of processing theory relies on circular reasoning? Think back to Baddeley's critiques we just discussed. Got it? It's because there is no independent objective index of depth. We define depth by what is remembered, and then we turn around and explain what is remembered by calling it deep. Total circle.
So, I want to leave you with this final, really crucial question. As you sit here engaging with this explainer, how are you actually processing it? Are you just passively letting the words wash over you in some shallow maintenance rehearsal? Or are you actively making connections, tying these psychological models to your own life, and really engaging in deep semantic elaboration? Because honestly, the way you choose to process this very sentence will completely determine whether you even remember it tomorrow. Thanks for diving deep into cognitive science with me today, and I'll catch you in the next one.